Now, today's lesson objective, as you see on the screen, is geared towards you being able to use the activity series of metals and non-metals to determine if a reaction will take place. We're going to explain what activity series is. Now, previously, we talked about 6 different types of reactions. We talked about synthesis reaction, decomposition reaction, single replacement reaction, combustion reaction, acid and base, as well as precipitation reactions. We talked about those 6 different types of reactions. And one of them was single replacement. We said single replacement is a redox reaction, which is oxidation reduction reaction. So we want trying to look at single replacement reaction because single replacement reaction is an important chemical reaction that occurs most times, and it happens around us, and it's a very important chemical process or industrial process. Now, at the end of today, you should be able to answer that question. How do you use the activity series to determine if a chemical reaction will take place? Now, the short background information I have there is of a silver cup. When this was made, the silver cup looked so beautiful. Okay? But after a while, chemical reaction begins to happen. You could see how ugly it is right now, with all those black and brown stains on it. Now, this is as a result of a chemical reaction that is occurring between the silver, because this is made up of silver. Silver is a pure substance. It's an element. Now, based on the activity series, silver, if you look at this, silver is reacting with hydrogen sulfide in the atmosphere. So let me show you the equation for that. So let's say we have silver. So silver is Ag. That's the symbol for silver. And then plus, in the atmosphere, you have H2S, which is hydrogen sulfide. Now, hydrogen sulfide in the presence of moisture, water vapor, is acidic. So what's happening here is that Ag is going to react with this and replace hydrogen to give you AgS plus hydrogen gas. So what we're saying is that this silver replaces hydrogen to give you hydrogen sulfide. Why is that possible? How is that possible? That is what we're looking at. Why is it that one element is able to displace another element in a given compound? Now, if I go back to our screen and move on to the next screen, you see this is where you have what's it called? Activity series. So in the activity series here, elements are arranged in order of their reactivity. Okay, so here lithium is the most reactive and gold is the least reactive. Just like the example we just saw, here you have magnesium plus copper nitrate. So magnesium is high in the activity series compared to copper. Copper is right here below magnesium. So which means that magnesium is more reactive than copper, and because of that, magnesium will displace copper in copper nitrate to give you magnesium nitrate and copper. Okay? Now, if you look at the second example, gold is reacting with hydrochloric acid. Gold cannot replace hydrogen because gold is below hydrogen in the activity series. So the cost now, let's say you have very beautiful gold necklace, and your little sister or brother is threatening you. Yeah, I'm going to mess up your jewelry with this acid. But because you know that gold is really below hydrogen, you know that that acid is not going to do anything to your jewelry, because it can't damage it. It can't, because gold is gold cannot react with that acid. It can't displace hydrogen from that solution. So you know that you're safe. Your jewelry is safe. So here, gold is not able to replace hydrogen, so there won't be any reaction. Now, this second part is the activity series for non-metals. Now, take note, the activity series for metals is separate from the activity series for non-metals. Although the non-metals are also arranged in order of reactivity from most reactive to least reactive. So here, most of them are halogens, group 17. Fluorine is more reactive than the other non-metals. So in this example, sodium bromide reacting with fluorine. Because fluorine is more reactive than bromide, fluorine can replace bromine in this reaction. It can replace bromine in this compound to give you sodium fluoride plus the bromine gas. But if this was iodine instead of fluorine, obviously that would not happen, because iodine is below, in this activity series, iodine is below bromine. So iodine cannot displace bromine, but bromine can displace iodine in that reaction. That's basically how you use the activity series to predict if a reaction will occur. Now, let's look at an example of what we have here. Here you see these are all the elements arranged in the activity series for metals. Now, this question says, the activity says drag the words into the correct boxes. Zinc reacting with copper sulfate. Now you're going to compare copper with zinc in the activity series. Now this is copper here, and this is zinc up here. You could say that zinc is higher than copper. Because of that, zinc can replace copper in this compound. So there will be a reaction. So in this case, it's going to be zinc sulfate and copper, because the zinc will displace copper in that reaction. But if you look at this here, copper and zinc, you could say that copper is least reactive than zinc. Copper is below zinc. So copper cannot replace zinc in this reaction. So this will be no reaction because copper is less reactive than zinc. So you can see here we are using the activity series to determine if the reaction given will proceed or not. Now, let's look at the activity series for non-metals. In the case of the activity series for non-metals, you can see right here that the non-metals are arranged in order of decreasing reactivity. So when we're looking at this example, make sure you're comparing the non-metal to non-metal. chlorine reacting with sodium bromide. You compare the chlorine, the activity of chlorine, with bromine, not with sodium, because this element, chlorine, is a non-metal. So you can't compare non-metal with metal. So you have to compare non-metal with non-metal. So we'll compare the activity of chlorine with the activity of bromine. So if you look at the activity series here for non-metals, chlorine is higher than bromine. Therefore, chlorine can replace bromine in this reaction. So you might end up having sodium chloride and the bromine gas, because here chlorine will replace bromine to give you sodium chloride, and the bromine would not be by itself. Okay? That's the same thing you do for the rest. You compare the single element with the non-metal in the compound given and see which one is more reactive. Whichever one is high above will be more reactive than the one that you have beneath. Okay? So that's basically how you use the activity series to predict the reactivity of a given reaction, if it's going to proceed or not. And that's a very short topic and lesson. I know it could be very confusing, but by the time you start practicing it and start looking at the activity series of metals and non-metals, it will become easier to comprehend. Any question for me? Any question for me, Kimberly? No? Okay. Fatima? Aisha? Aisha, are you there? What about Juan? Juan, Aisha, talk to me. I hope you've not gone to sleep or taken an afternoon nap. All right, I assume that if you have questions, you will ask. So that's it. So you guys complete the rest and then just shout out, ask questions if you have them. Okay? Let's stop recording.